Hello dear students, welcome back. In the last class we discussed about two cases of distance time graph, isn't it? What were the two cases? First case, when the object or the material is at rest. What happens to the graph? The nature of the graph was a straight line which is parallel to the x-axis, and in x-axis we took time and in y-axis we took distance, isn't it? So that was the nature of the graph we got for the object at rest. Second case is that object following a uniform motion. Uniform motion means it changes its position equally in equal interval of time. If it changes its motion equally in equal interval of time, we get a straight line which is inclined to the x-axis. That were the two cases we discussed, and from that case we discussed how to obtain the slope of the graph. And slope of the graph, distance time graph, is equivalent to speed or velocity. Slope of distance time graph is equivalent to speed, and if it is displacement time graph, the slope is equivalent to the velocity. Now we are discussing about the third case. The body is in non-uniform motion. What is non-uniform? It covers unequal distance in equal interval of time. So I have an example here. See, I take equal interval of times and the distance covered in each interval of time. See here, in the first second it covers 5 meters. In the second one it covers 15 meters extra, so it reaches at 20. So in the first it is 5, second it is 15, the next one it is how much? 25. 20 plus 25 equal to 45. Next one it is 30. It covers a distance of 30 in the last second. So it covers unequal distance in equal interval of time. So this is a non-uniform motion, and this non-uniform motion is also known as accelerated motion. And the uniform motion is equivalent to zero acceleration. Why there is no acceleration in case of uniform motion? If the body covers equal distance in equal interval of time, its speed is always the normal. So the difference between final velocity and initial velocity is zero, as there is no change in the speed. Speed is always the same, but here there is a change in the speed, isn't it? So that's why if there is a change in the speed, it is accelerated motion or it is non-uniform motion. Now we can discuss the graph. Let's look the graph of this data given here. Time 0 and distance 0. So we can mark the point here, time and distance 0. Now next one, time 1 second, distance 5 meters. At 1 it is 5. Let us mark here, almost here. 10 will be here, so the half of 10 here. 5, we marked 5. At 2, 20. Okay, here 220. At 3, 45. 45 means almost here. At 3, 45. At 4, 75. 75 means almost near to 80. So we could mark here. See, we got 5 points, 0, 0, 1, 5, 2, 25, I think 220, 3, 45, then 4, 75. These are the 4 points. Along with the 0, 0, that is the fifth point. So we can join these points. See, these are not in a single line. So the line is a curved one, isn't it? It's not a straight line, so we get a curved line. In the case of uniform motion, we got a straight line, but in the case of non-uniform motion, see the curve is a curved one. So we get a irregular curve for non-uniform motion. That is the conclusion we got from this. That is, when we consider the data of a non-uniform motion and when we plot it in a graph, we got a irregular curve. Now another set of data. Here we have, see here, at time 0 it covers a distance of 0. At first second it covers 20 meters. The second one 30, 35, 37, 40. Is there any difference between this data? The two are non-uniform motion or accelerated motion, isn't it? See here, it does not cover equal intervals, equal distance in equal interval. These are equal intervals of time, but it covers different distances. In the first second it covers 20. In the second one it covers only 10 meters. In the third one it covers only 5 meters. In the fourth second it covers only 2 meters, and last one it covers 3 meters. These are not a regular type of thing, isn't it? At first it covers more distance, then it is decreased as we are going here. So what happens in the case of speed? Speed will be increasing or decreasing. The first second it covers 20 meters, so at that time the speed will be almost 20 meter per second. In the second one it covers only 10, so the speed will be 10 meter per second only. The third one it is 5 meter per second, 2 meter per second, 3 meter per second. So the speed is decreasing. So if the speed is decreasing, an accelerated motion, for an accelerated motion, if the speed is decreasing, that means it is called retardation. That is the negative acceleration. Acceleration is not increasing, is not in the increasing order, but is in the decreasing order. See here we have 5 meter per second, here we have 15 meter per second, here we have 25 meter per second, here we have 30 meter per second. The speed is increasing, therefore we get a accelerated curve. And now here we have a retard motion, that is the speed is decreasing. Let's draw the curve of this motion. At 0 is the same 0 here, so we can draw in the same graph itself. Okay, so I need not draw any other graph. Or if you have any confusion, I will drop this. Okay, you have to draw anyway in the different graphs. 0, 0 is the first point. Okay, right. Then at first second it covers 20, so it's almost here. If you are drawing in the graph, you will get an accurate thing. At 2 it's 30, 30 will be here. So I have the second point, 335, sorry, 3 here, 35. At 437, at 437 means here, and at 540, that means here. See the nature of graph, and we join these points. We get a curve like this. Is curved downwards. In the case of accelerated motion, it was curving inwards, upwards, isn't it? It was curving upwards towards the y-axis. See, now the curve goes towards the x-axis. So that is the difference between accelerated motion and a retard motion. So this is the graph of retardation, not acceleration, retardation, negative acceleration. So generally we can conclude that in a distance time graph, if it is a straight line, the body follows zero motion, or the body is at rest. If it is a straight line inclined to the x-axis, that shows the body follows a uniform motion, and this line will be, this is a straight line which is inclined to the x-axis. In the next case, if it is an accelerated motion, it will be a curved line curving towards the y-axis, that is the accelerated motion. And in this case, acceleration is equal to 0. Here acceleration is positive. And next one, the last case we studied, acceleration is equal to negative, or the graph of retard motion. So that's all about the distance time graph. is the graph of an object at rest, graph of a object following uniform motion, non-uniform motion in the accelerated motion or accelerated motion. The graph of non-uniform motion where acceleration is negative or retardation happens in that case. So that's all about distance time graph. Hope it is clear for you. I told from the first, that is from the at rest 3 cases. There are only 3 cases, very easy thing. Case 1 at rest, case 2 in uniform motion, case 3 in non-uniform motion, and based on the graph we can tell the nature of a motion by just seeing the graph only, and we can find the slope of the graph if it follows only a uniform motion. That is, in the portion of following uniform motion only we can find the slope of the graph, and the slope of the graph gives us information about the speed or velocity the object is taken. So that's all about the distance time graph. Hope you understood. Thank you for watching.